This next project challenge is called Pepper's Pill Mill. In this challenge, the students are focusing on two primary components. One is file I/O. They have to read input from some files and they have to produce output and write that to a file. And the other thing that they're being challenged with in this project is the implementation of a class in Java according to specifications. So let's go ahead and read through the directions, then we'll take a look at the grading rubric to understand that, and then we'll look at a couple of examples and see how the rubric is applied to those student submissions to determine their scores. It's always a good idea to start with reading the directions and making sure that you have a pretty solid understanding of what the students are being asked to accomplish here. So Pepper's Pill Mill is a pharmaceutical company that's developing a new drug to help fight Alzheimer's disease. The drug has performed well in laboratory experiments, and the company has received approval to begin trials with people. To make sure that the trial is unbiased, they're asking you to develop a Java program that can perform the data analysis and determine the drug's effectiveness. Each trial consists of 3 groups of individuals undergoing a different treatment: a control group with no treatment, an experimental group that gets the new drug, and a placebo group that gets a fake drug. Every individual in each group gets the same memory evaluation, and the doctor will write a score for that individual as the number between 0 and 100. There are many patients in each group, so some simple statistics are necessary to determine the effectiveness of a treatment. For input and output, your program should take as input the names for 3 input files, one for each group in the trial, and a file name for the output file. Your program should output to the file a file with the test results. Your program should ask for the names of 3 input files that contain memory evaluation data for the 3 groups in this trial. Your program should then ask for a name for the file that will hold the trial results, the output file. So the input's going to be 3 file names, and the output and an output file name. So 4 inputs there that the user is going to type in. Each input data file contains a list of integers, 1 on each line. The study is double-blind, so your program will not know which data file corresponds to which experimental group. Additionally, the group sizes may be different. So students know they're going to be opening and reading files that contain integers, and the number of integers in each file might be different, and what they're told is that each integer is on a separate line. For each input file, your program should read in the data from the file. Your program will need to calculate the average and the standard deviation for that data set. Your program will also need to determine if there's a significant difference between each pair of groups in this trial. To determine if there is a significant difference between 2 groups in the trial, your program must compute the positive difference between the averages of the 2 groups. If the difference between the averages is larger than the standard deviation of both groups, then this is considered a significant result. For example, given the following statistics, if Group 1 has an average of 69 and a standard deviation of 18.42, Group 2 has an average of 47 and a standard deviation of 19.92, and Group 3 has an average of 51.58 and a standard deviation of 19.2, then there is a significant difference between Groups 1 and 2, because 69 minus 47, the difference between their averages, is greater than both of their standard deviations. On the other hand, there's not a significant difference between groups 1 and 3 because the difference between their averages is not greater than at least one of the group's standard deviations. So this is their method for determining whether or not a statistically significant result is obtained between any 2 groups in the set of 3 groups. Your program should write the results to an output file. The file will have 2 sections. The first section, statistics, will list the name of each input file, followed by the average and the standard deviation for that file. The second section, results, will list the names of the 2 files being compared and an indication, true or false, of whether or not the result is significant. Here's a generalized example of the output file format. Statistics section, data file name 1, average for this file, standard deviation, same thing for file 2 and file 3. And then results section, data file 1 compared to data file 2. Is there or is there not a significant result here? And the same thing for the other 2 pairs of data files. This is the required class that they're being asked to implement. In addition to the class that contains your main method, you must implement and use the following trial group class in your program. This class will be used to instantiate objects that will represent each of the 3 groups in a trial. Each trial group object will store the important information for one trial group: the name of the file containing the group data, the number of data points in that file, the sum of all the values in that file, and the sum of the squares of the values in that file. These stored values will be used to calculate the average and the standard deviation for the group. The trial group object will also be able to determine and return the average of the values in the group, the standard deviation of the values in the group, and the name of the file that the values came from. And then they're giving a simple UML class diagram here with some specification information: the name of the class, your private instance variables, names and data types, and your public methods, including constructor with arguments and return types. And we're asking them to implement this strictly according to these specifications. The constructor for the class must initialize a trial group object by storing the file name that's passed in as an argument. So it's going to store the file name in the private instance variable, opening the file whose name is passed in, reading the values in the file and determining the count, sum, and sum of the squares, and storing those in the instance variables. So all of that functionality we expect to see in the constructor for the trial group class. The getFileName method will simply return a copy of the string stored in the instance variable file name. The getAverage method will compute and return the average of the values in this trial group, and the getStandardDeviation method will compute and return the standard deviation of the values in this trial group. And then they're given a method for determining the standard deviation of a set of numbers, which is convenient and consistent with the implementation that they've been given. So we're not asking them to figure out how to do a standard deviation. We're just asking them to implement it. They're basically being given the specifications for that. So the following values: count, sum of squares. With these values, you can compute the standard deviation like this. First, you compute the average. Next, you compute the square of the average. Then you compute the average of the squares, and finally you compute the standard deviation as the square root of the average of the squares minus the square of the averages. So they should be able to implement this functionality in this method. You may add any attributes, variables, or operations methods that you wish to the trial group class. However, you may not delete or change the details of any of the attributes and operations in the given class diagram above. So they can't change the names or the data types or the visibility of any of these elements that are specified. They will be given test data files that they can test their program against, and all of that's available in Vocarium. And then there's a list of things for them to think about. Think about breaking the problem down into simpler problems, so they might implement some simpler methods to do some of the sub-computations required for something more complex. They should follow the recipe of collecting all the information first, computing the required results, and then outputting the results. They should spend some time choosing their variable names carefully, make sure that they're descriptive. Take advantage of variables to name values whose purpose may not be obvious. So in some of their computations, we would rather not see really long lines of complex expressions. We would rather see those broken down into simpler lines, simpler expressions with intermediate values stored in a variable with a descriptive name. And then be sure to follow the basic style guide that they've been given. The grading rubric is pretty familiar: 10% for syntax, full credit for no syntax errors and enough code. If there's one syntax error, they get 80% of that 10%, or 8 points. If there's 2 or 3 syntax errors, 6 points, and so on. For correctness, the automated grading system stands a pretty good chance of being able to determine this, but of course not in all cases. If it produces correct outputs for all the test inputs, they'll get full credit here. Otherwise, it'll break down according to these values, passing all but one or two of the tests, passing most of the tests, passing some of the tests, or passing no tests. For style, meaning all the style guidelines, so we're looking for things like descriptive variable names, good use of indentation and white space, breaking large complex lines down into simpler ones. There's 10% for the file I/O if their program opens and reads from the 3 input files and the program opens and writes to an output file. That's full credit. So there's no connection to correctness here. We're just evaluating their ability to open and read from files and open and write to a file. We aren't concerned with assigning points to this based on whether they do this correctly with regard to the problem specification. On the other hand, if they can open and read from an input file or open and write to an output file, they can get partial credit and so on. For the user-defined classes, this is a big chunk of their grade, is implementing that class according to specifications, 30% of their grade here. If they implement and use a trial data class, and this includes the specified constructor and all 4 specified instance variables and all 3 specified methods, full credit. Otherwise, it breaks down according to they implemented and used a trial data class, and this class includes the specified constructor, at least 2 of the specified methods, and at least 2 of the specified variables, and so far. And as usual, we have additional grading aids down here with some templated feedback that you can use as you're grading these, and there's a target solution for you to refer to, and you can pull code snippets out of here and paste that in if you want to give students some examples on how they could correct their code as a means of feedback. All right, let's go ahead and look at a couple of example submissions that students turned in and sort of compare that against the rubric and see how their submissions should be evaluated against a rubric. So here's one here, and it's already been graded. But we'll go ahead and usually what I would recommend doing is taking a look at the Vocarium report that gets produced. And this is produced by the automated grading system, but this gives you a really good high-level overview of how their project is meeting the specified requirements, at least what can be viewed and reviewed by the automated grading system. So we can see that it gave this student an 8 out of 40 on correctness. So this means that most of the test cases did not produce correct outputs. For file I/O, it was not able to determine any correctness there. For style, this is always something that we're going to have to do manually. For syntax, the automated grading system was able to determine that their code does compile. There are no syntax errors in there, and there is a significant amount of code in there. And then for user-defined classes, it gave them a 6 out of 30, which I believe is the lowest possible score there. So there's definitely a problem with their implementation of the user-defined class, which probably relates to this file I/O problem and this correctness problem. And then if we look a little further, we can see that the automated grading system detected the Pepper's Pill Mill class, and that this class has no instance variables and 2 public methods, one called main and one called f_1_counts ints and mean in file 1. So this student obviously struggled with this project. So at this point, we could go ahead and take a look at their code and see what actually happened in here. There's this kind of monster method that they put together that has hard-coded a file name and is attempting to read from that file, doing some system.out.print lines. There's a lot of really strangely named variables in here. There's that second file, there's that third file, so they've hard-coded all of this. There's redundancy in here, and then their main method just calls this one giant method. So this student is obviously struggling with the concept of object-oriented programming in general, and appears to have made no attempt to implement the specified class. So that's obviously going to show up in the grading rubric. So if we take a look at the rubric, again, the auto grader gave them full credit for syntax, minimal credit for correctness. We're going to have to grade their style. They are doing some file I/O, so I would go ahead and give them, and this grader also did give them credit for that. They're doing the file I/O. They're opening files, they're reading from files, and they're writing to files. And so I think according to the rubric, they should get full credit on that as they have. For the user-defined classes, they did not implement a user-defined class other than the Pepper's Pill Mill class, so minimal credit on that one. So, and that's reflected here as well. And let's take a look at the feedback that this grader gave this student. So the feedback here is Java is an object-oriented programming language, and the best way to use this language is to help solve problems is to design and write classes. For example, you could have designed and written a class to represent a trial group. This class could store all the essential information for a trial group and could perform all of the functionality associated with the trial group. For example, calculating the average and calculating the standard deviation. Also, many of your variable names could be more descriptive. And that's absolutely true. So there's a lot of problems with this student's submission. This feedback focuses on the two biggest ones. And obviously the student has struggled. If I were to add anything to this, it might be a little bit of encouragement to let the students know, take advantage of the online discussions, reach out and let us know if you're struggling with an assignment. Definitely start early on an assignment like this, and encourage the student to continue through the course. Let's take a look at another example. Again, I'm going to start with Vocarium's report output. Here, the auto grader gave them 32 out of 40 on correctness, which means that almost all test inputs produced correct outputs. The auto grading system was able to determine that their file I/O was working correctly. That's consistent with its ability to run these tests and get those output files. Again, we have to grade the style manually. Syntax is good, and gave full credit on the user-defined class. And all the auto grading system is doing is looking for a class with that name that has the specified instance variables with the appropriate names and data types and visibility, and the same thing for the specified methods. But we can go ahead and take a look at the code and see what it looks like. So here's the Pepper's Pill Mill class with the main. They're inputting their file names. And instantiating the trial groups based on those file names. Then they're starting to put together their output. And then they're writing their output to the file. I think this large main method could have been broken down into some simpler methods. There's some redundancy going on here, so that's another indication that they could have broken out some simpler methods from this main method and called those, but not a big deal. I'm looking at their variable names. They're verbose but descriptive. And then if we come down and we take a look at their trial group, we can confirm that it does meet specifications. They've added 1 or 2 instance variables, and that's totally acceptable. This is a little odd here. Their constructor is not doing what the constructor is specified to do. So if we look back at the instructions, we can see that the specifications for the constructor tell the student that their constructor should do these things. It should open the file, read the file contents, and store the appropriate data in the instance variables. And that does not seem to be happening here, so I would probably make a comment on that. And that must be happening somewhere else because this is producing correct outputs. So if we look at the get average, we can see sure enough in here they are opening a file, reading through the file, collecting the data that they need, and in the get standard deviation they're doing the same thing. So again, they've got a lot of redundancy going on in the code here. They've got a functional solution. It meets almost all, if not all, of the specified requirements, but the design could be better. So let's take a look at what comments this grader gave as feedback. Overall, very good work. Your trial group constructor does not perform the specified operations. 1, open the file. 2, read the file contents. 3, store the file data in the instance variables. This would simplify your code and allow you to open and read the files only once. That's a good comment. One small point of improvement might be to shorten your longer lines by storing concatenated strings before writing them out. So that's a reference to these lines here where this student is producing the output for the file by concatenating strings together. Rather than having that wrap across multiple lines, you could break that down and simplify that a little bit. I agree. I might also comment on the size of the main method and the fact that there's some redundancies in the main method and that the main method is doing some distinct things, and that those redundancies and those distinct things could and should be factored out into separate methods in the Pepper's Pill Mill class. But overall, a very good job of meeting the requirements. Let's look at one more example here. Again, we'll start with the Vocarium report. This time the autograder gave them full credit for correctness, which means that their code produced correct outputs for all test inputs, which validates the file I/O. Again, as always, we have to grade the style manually. The autograder obviously gave them 10 of 10 on the syntax and 30 of 30 on the user-defined classes. And you can see that the auto-grading script put together an approximation of a UML representation of their trial group class, including the instance variables and the methods. And they implemented this obviously exactly according to specifications. So let's take a look at the actual code and see what's going on in there. So they start with their trial group class. Here are their private instance variables. Here's their constructor. They initialize their instance variables. They open the file, read the file, store the values. For getting the average, they just use those computed values that were computed in the constructor. And for getting the standard deviation, this is nice. They've broken it down into separate lines. This is good work. This returns the file name. Here's the Pepper's Pill Mill class. They've broken this down into a couple different methods, which is good. This student is on a great track here. I have no real complaints about what this student is doing. They're getting full credit for all rubric criteria, and the comment here is great job. If anything, I might add a little bit to this and specify what parts of the work that the student did I think are great. You might say, great job following the specifications for the trial group class. You did a good job of breaking down complex lines or complex processes into simple pieces. You even took advantage of creating an additional method to simplify the mainline logic in your Pepper's Pill Mill class. But this is a great job. So there's a walkthrough of grading the Pepper's Pill Mill project challenge. I hope this was helpful.